Hey there, awesome physics students. I wanted to take a second to talk about how the resistance and the capacitance in a RC circuit affect the time constant. Now you probably know from looking at the equations in those that the product R times C gives you the time constant tau. And you can see from looking at those equations why changing R or C will change the charging or discharging time. But I want to give you some intuition about why that might be instead of just looking at the equations. So I have a charging circuit and a discharging circuit here. Now I want to just focus on the charging circuit because I think this, what I'm going to say here applies to both, but let's just concentrate on one because it's going to apply over there just as well. So let's look at this. We have a battery with voltage V0 and we're using it with a resistor R and a capacitance C. Let's think about what happens if I change the capacitance here. So we know that the capacitance, just from the definition of capacitance, is the ratio charge on the capacitor to the voltage at which that capacitor is charged. But we're going to charge this capacitor up to the voltage V0. So this is the voltage of the battery. That's not going to change. So if I make the capacitance huge, I fluff up that capacitance, that's still going to be the ratio of charge to voltage, but the voltage is the same old battery voltage it was before. This means that what really must change is the amount of charge that I'm putting on the capacitor. In other words, making the large capacitor means that I'm going to have a lot of charge that I need to get on there. And of course, if I need to transfer a lot of charge, but the rate is staying fixed, the rate at which the charge comes on there, I got to wait a long time for that charge to get on there. So my point here is that C is controlling the amount of charge that is transferred. Okay. Now, what does the R affect? Well, the resistance affects the charge rate. So remember that V equals IR. In this circuit, the V is the voltage of the battery. So that's not going to change. Now, if I make R really small, what's that going to affect? Well, if I make R, let me just do it down here. If I make R really small, it's going to be a small resistance. That means that the product IR has to be the same as the voltage of the battery, at least in the beginning. And so that's going to make the current huge, right? If I have a very tiny resistance, that's going to allow a huge current. But the current is the rate at which this charges. So that means the rate at which this charges, or the charge is transferred there, is really quick. And those charges are going to be able to fill up that capacitor right away. Think of this like a tube. You know, if you make the tube really narrow, it's a high resistance. The charges aren't going to be able to get through that narrow tube very easily. It's going to reduce the rate at which they can get through there. Or if you make a big fat tube, that's going to correspond with a very small resistance, and that's going to allow you a large flow rate or a large current. The rate at which the thing charges can be huge. So the R controls the rate of transfer. Okay, so by turning the capacitance up or down, or turning the resistance up or down, we directly affect the charging or discharging time, right? With the size of the container, which dictates the amount of charge, or the pipe through which it travels, the rate of transfer of the charge. All right, hopefully this helps you give some intuition about how this affects that. All right.